Here's the question. Now, how do we make this cup such that the amount of material spent will be least? So, in other words, we want consume the least amount of material to make this cup. Well, it's an interesting question, right? Now, let me put it this way. For example, if I want to make a half-liter cup, so I can make the cup like this, right? Okay, that cup, has a capacity for half-liter. Or I can make the cup like that. It has a capacity of half-liter. But they spend quite more material compared to this one, you see. Some kind of dimension between these two. Definitely this will spend less material to make, right? So logically speaking, that there exists more reasonable dimension of the cup, which will consume the least material. That the cup spend the least material to make, I call a most economical cup. Okay, now how do we start? This one has no numerical data given. So, okay, now how do we start? Okay, let me list those things. Okay, now we have a height, h. We have a diameter, d. What other things do we need to consider? The capacity, the total volume of the cup it can hold the liquid, and the total amount of material. Now I consider the material is we don't mind what kind of material, right? The material is porcelain, glass, metal, or wood, as long as the thickness is uniform. Therefore, we will consider the total amount of area of the material spent. Okay. Now, the cup, if it has the cup, right? This material is this will be diameter times pi, right? This will be h. So total amount of area is h d pi. That's the amount of a material lateral side, right? And also there's a base. The base will be, total amount of area would be pi r square. So it will be pi over 4 d square, right? Okay. So the volume, the capacity will be the base area times the height, right? So this is quarter pi d square times h. The total amount of area will be equal to dh pi, that is this one, plus quarter pi d square. Now, since we want to have a minimum amount of area. Therefore, we want to minimize this function. Whereas h and d, we have to delete one of them because we want a one variable function. So from v, we have h is equal to 4v, right, over pi d square. Okay, so a will be equal to d times pi times h. H is this, right? Pi d square 4v plus quarter pi d square. So this means that a is equal to d pi cancel out. This is 4v yeah, 4v d plus quarter pi d square. So finally we have a function. A is a function of d. Now we want to minimize a, so we just find the derivative a with respect to d. So this will be negative 4v d square, right? Yes, plus half pi d. D is positive, right? So finally we have a function, and if dd is equal to 0, that means from this equal to 0, we have a d cube is 8v over pi. Okay. We want to find the ratio. Well, I don't use r because r is confusing with the radius. I'm using k. K is the ratio between the height and the diameter. And height is 4v over pi d square. And over d, right? So this is equal to 4v pi d cube. And we plug a d cube over there, right? Therefore equal to 4v the 8v, right? So this is equal to 1/2. So finally we get our solution b, k is equal to 1/2. That is our result, which means that if the cup the diameter is twice as the height, that cup is the most economical. Okay? If diameter is twice as the height, well, then this cup is the most economical, which means it will spend more, the least amount of material to make. See, my cup, the cup I'm holding, looks like the most economical one. Now, okay, this is just purely based on mathematics consideration, right? It's not based on artistic point of view. Forget aesthetics. Okay. So this is a very nice question, no? We start from almost, the no numerical data given. Finally, we get a very, very nice result. See, this cup is not economical. maybe beautiful, but not get so this was not economical, maybe beautiful, but not least amount of material to make. So that is one. This type of cup is the best. You see, no matter, well, just for the given amount of capacity given, right? So, okay. Thank you for your watching.